Okay, so we're back to addition of ordinates, and remember we covered this back in chapter 1, right at the start of the year, and we can do it now for questions that involve functions from chapter 4 to 6 as well now. Now, when would we use addition of ordinates? So just say an exam 2 question has a question like, or an exam 1 question has a question like h of x equals e to the x plus x. And you sort of start to think, I don't really know what that looks like, all right? So if this is exam 1, we don't have a graphics calculator, so we can't get a look at it, okay? So what you've got to actually identify is this h of x function is assembled by using 2 functions that we actually know. So I know the graph of e to the x, that's just the standard exponential function, and this one here is just the standard linear function, okay? So I wonder what they would look like put together. So the best way to do it is actually to use the addition of ordinates process. So to grab the individual graphs, f of x and g of x, which let's say f of x is e to the x and g of x equals x, and plonk them on a Cartesian plane, and then use the process of addition of ordinates. Okay, so how does this work? Well, remember, you do need something pretty accurate to do it. So what I can see here is this is going to be 0 plus 1, which is equal to 1. So I just consider what the y values are, okay, and add those ordinates together. So this is 1, and this is a bit less than 2. So 1 plus a bit less than 2 is going to be 1 more than that. It'll be somewhere up here. So we can see that what's going to happen on this side here is it's going to closely follow that, but it's going to go a little bit more exponential, because what it does is it adds this linear component to the already growing exponential component. All right, what about on this side of the Cartesian plane? All right, so what I tend to look for is an x-intercept. And you'll note here that what I can see is, see the distance from there and the distance from there? I would say that they're roughly the same. What that means is that we've got an x-intercept, because this is negative, what is it, negative a half? This is positive a half, and when I add those 2 functions together, I'm going to get an intercept roughly there. All right, down here, what I can see is I've got this value here, negative 2, and I'm going to add a small positive value. All right, so it's going to be maybe there. Now, as you can see here, what we're going to get is another small positive value. And what you might note is that this is one of those situations where we get an asymptote other than the vertical and horizontal. We're going to get an asymptote along the line y equals x. So this line here is actually going to be our asymptote as well. Right, and what we can do is run our function along the line here. Okay, it starts veering away. Let's try that again. So run it along the line. Starts to veer away. Oh, this is just awful. Sorry, girls. But yeah, and my excuse is, again, this little tablet thing that I've got in front of me. Right, so go through the x-intercept, hit that point, and curve it through, okay? So again, you notice that my first attempt at this side here, the shape didn't quite match the left-hand side. So to do addition of ordinates, you're going to need like a rubber, get the idea of it, and then plot one nice clean line. But generally speaking, it's not actually to graph the function itself, but to use that graph to produce something else or to answer a particular question. So all this is going to do is sort of allow us to just visualize what the answer might roughly look like. Let's actually have a look at it. So we'll go main, no, we'll go graph and table. Let's just check out e to the x, shift 4 plus x. All right, so as suspected, looks very much like that. What the x-intercept is, analysis, g-solve, root, negative 0.56, not bad. All right, so that's by sight. The value of it is negative 0.56. All right, so what you'll need to do for this particular exercise is grab the printed graphs. Okay, so I'll put them on Firefly and have a link to them. And there's also a sheet, sum and difference of functions, and do all of them. Okay, so all of those links will be included for you.